We have another few examples here with different laws. Here we have t varies inversely with s. T varies inversely with s. So I'm going to write down that general formula, t equals k over s. So t equals k over s. So if we need to go back and look at our laws right here, y varies inversely as x. Well, this was t varies inversely with s. So there's our general formula. Then it says when s is equal to 15, t is equal to 20. So we're going to put a 20 in for t. We're going to leave k because it's still unknown, and we're putting a 15 in for s. Now I'm going to solve for k by multiplying both sides by 15, and I get k equals 20 times 15, which is 300. Step 3, we're going to write our specific law, t equals 300 over s. So let me show you. This k is the same as this k right here. So we're just going to fill that in. And now it says find t when s is 18. So find t, so t equals 300 divided by 18. 300 divided by 18. So I'm going to reduce that slowly but surely. You can do baby steps. You can divide both the numerator and the denominator by 2. We get 150 over 9. Then we could say, oh, well, 3 goes into both those numbers. So that would give us 50 over 3. And I think that that's our nice reduced form. Therefore, t is equal to 50 over 3. Not too bad, not too bad. If you get the practice, make sure you're doing all your steps. Make sure you're doing all your steps and you'll be great. Okay, suppose z varies jointly with x and the square of y. So suppose z varies, so that means z equals, so this is our first step. Let's write our law out. Z equals, well, k is always in the numerator. I don't know if there's a denominator, but if there is, k is going to go in the numerator. Varies jointly with, that means I'm going to be multiplying things together. X and, so x, what are the two things that we're multiplying it by? X and the square of y, not the square root, but the square of y. And there is no inverse, so I don't have a denominator. So this is beautiful. Step 2, I'm going to sub in my values. When x is 4, y is 5, and z is 300. So we'll put a 300 in for z. For x, we're going to put 4. And for y, we're going to put 5. So that would be 5 squared. And now I need to solve for k. So some of you would say, well, 4 times 25, well, that's 100. So 300, actually, that's not my third step. I need to solve for k right here. So 300 equals k times 100, and then divide both sides by 100. So k equals 3. And then a third step, that's rewriting z equals 3xy squared. So that's our specific law. So this is our specific formula for this problem. Specific formula for the problem. And we're going to use the specific formula to solve. So now it says find z when x is equal to 6 and y is equal to 2. So step 4, find z when x is equal to 6 and y is equal to 2. I don't know if I said 4 a second ago or not, but it's 2. So z equals 3 times 6 times 4. So that's 18 times 4. Or we could say 12 times 6. No matter how we do this, 3 times 6 times 4, 12 times 6, 24 times 3, 18 times 4, we're going to get z equals 72. So there are a couple more examples. Coming up, we're going to do some word problems. So this was the basics, but coming up in the next video, we're going to do some word problems where we're actually putting these to application. Actually putting this to application.